Okay, this is the practice question for arable organic chemistry and especially for A2 because this is related to aromatic chemistry. And it is also valid for intermediate chemistry as well. Benzene, that is C6H6, reacts with chloroethane, that is chloroethane or ethyl chloride, in the presence of suitable catalyst to form ethyl benzene. In presence of the catalyst, the ion, that is carbocation, is formed. This ion reacts with benzene. Complete the equation for the reaction of C2H5Cl with this catalyst to form this carbocation, that is C2H5 plus as one product. So we have to complete it. So what to do? The best catalyst for this reaction is aluminum chloride. So aluminum chloride, when aluminum chloride reacts with it, it forms this carbocation and aluminum tetrachloride anion. So this anion is also formed. Okay, this is part B of the same question. Ethyl benzene reacts with more C2H5Cl, forming a mixture containing 1,2-diethyl benzene and 1,4-diethyl benzene. Now draw the structure of 1,2-diethyl benzene and 1,4-diethyl benzene. So if ethyl group is substituted here, CH2, CH3. So for 1,2-diethyl benzene, another ethyl would be there. So this is 1,2-diethyl benzene. And for 1,4-diethyl benzene, you can draw here. This is the benzene ring. First ethyl is here. And another on the fourth position, 1, 2, 3, 4. So in A level, we just write one type of nomenclature that this is 1,2-diethyl benzene and is 1,4-diethyl benzene. But in intermediate and in general organic chemistry, this 1,2-diethyl benzene is commonly known as orthodiethyl benzene. So you can write instead of the whole word ortho, O diethyl benzene. And for 1,4, this is called the para position. So you can write para diethyl or the para p diethyl benzene. But remember that in A level, these ortho and para terms are not used. Now, explain why there is a little, very little 1,3-diethyl benzene, and this 1,3 is usually known as meta-diethyl benzene in intermediate and general organic chemistry. But the IPC name is 1,3-diethyl benzene, and Cambridge use only the IPSC names for the ease of the student. Explain why there is very little 1,3-diethyl benzene. So remember that alkyl groups are ortho-para directing, means 2,4,6 directing groups. And I'm using a specific organic chemistry term that is called regioselectivity. Although this term is neither in A level or nor in intermediate chemistry, but regioselectivity means multiple products are possible, but one or two of them are predominant. So the other product can be there, but in very little quantity. So as we know that ethyl, this ethyl group is 2,4,6 directing group, but a little 3 directing product can be there. So the answer you can write here that ethyl is a 2,4,6 directing group, so the major products, so the two main products are 1, 2, and 1, 4. But 1, 3 product is also formed, but in a very negligible amount, very small quantity. So remember that radioselectivity means not only one product is obtained, but more than one product can be obtained, and some of them are the main product which are synthesized predominantly, other in very small quantity or negligible quantity. Now this is part C. 1,2-diethyl benzene can be oxidized to phthalic acid, that is benzene 1,2-dioic acid. This is benzene 1,2-dioic acid. Its molecular formula is C6H4 CHH twice, and the structure is given here. So state the reagent and conditions used for this reaction. So actually what is there? It is the conversion of 1,2-diethyl benzene. So that was 1,2-diethyl benzene. And what changes has been occurred here is the conversion of this ethyl group into carboxylic group. So this is the oxidation reaction. And in this oxidation reaction, we use hot alkaline caminophore. Or you may write this answer as aminophore minus OH, any hydroxide containing reagent, sodium hydroxide or potassium hydroxide, and plus heat. So this reaction is required to convert this ethyl or any alkyl group into carboxylic group. Now complete the overall equation for this reaction. An atom of oxygen from the oxidation agent. So oxidizing agent is caminophore. So from there we can take only oxygen in atomic form. And all of the atoms in the two ethyl groups are fully oxidized in this reaction. Fully oxidized in this reaction. Okay. So we have to write the complete equation. So here 1,2-diethyl benzene. So the 1,2-diethyl benzene formula should be C6H4 C2H5 twice. This is one way. Or you may write this formula. How many carbon is total here? 2 and 6, 8. So you can write C8, not 8, sorry. 2 twos are 4, 4 and 6, 10. C10. And hydrogen, 5 twos are 10, 10 and 4, 14. So T C10, H14, and the product is C6H6, C6H4, CHH twice. And if there is alkyl group other than methyl, then carbon dioxide is also formed. And how many carbon dioxide molecule will be produced? It depends on the extra carbon atom. So one extra is here, one extra is here. So minimum 2 carbon atoms will be converted into carbon dioxide. And water is also produced in all the gases. So what to do? Now balance the chemical equation as there are C10. So total 10 carbon atoms should be there. So C6 and 2, 8, 8 are there, 2 are here. So there should be 2 carbon dioxide molecule. We are okay here. And how many hydrogen are there? 14 hydrogen are there. So there should be 14 water molecules. Sorry, 7 water molecules. So there are 7 twos are 8. But remember that we have to calculate all the hydrogen atoms. So 4 are here and 2 are here. 4 into 6. So 14 minus 6 are 8. 8 is there. So 8 hydrogen should be more here. So 4 water molecules can be written here. So 4 oxygen here. 2 twos are 4. 4 oxygen here. So total 8 oxygen and 2 twos are 4. 12 oxygen are already there. So if we write 12 here, then oxygen must be balanced. So in this way, we can balance oxygen atom as well. Now the question is regarding predict the number of peaks in carbon C13 NMR. C13 NMR. So how many carbon peaks should be there? Now we can draw the structure here, or you can see by scrolling up. C2H5, or better to draw CH2, CH3, CH2, CH3 here as well. So if we see there is a symmetry in the molecule. So the peak of this and this would be same. So we can say 1, and say another signal would be like would be for this. So this is 2, both are 2. 3, 4, and 5. So there should be 5 signals in C13 NMR for this molecule. But we are not asked about this molecule. We are to do for the 1,2-dioic acid, not for this molecule. So draw it again. CHH, There is another COOH. And again, this molecule also has symmetry. So you can divide in two halves. So one for this carbon, and both are the same carbon atoms. These two are the same carbon atoms. So second signal would be due to these two carbon atoms. And these two carbon atoms are also similar. So these two carbon atoms, you can number it 3. And this is the fourth one. So total 4 signals could be there. Now this is part D of the same question, that proton NMR spectra of ethyl benzene. Ethyl benzene is not diethyl benzene. Ethyl benzene is this CH2, CH3. And benzene 1,2-dioic acid. This is benzene 1,2-dioic acid. In CDCl3 are shown. So these are the proton spectrum. So how many protons are there? If you see that 1, 2, and 3 signals are there. So actually the signals between C6 to C8, chemical shift 6 to 8 are due to the carbon atoms of the benzene ring, and these are the two signals due to the side group. So at low chemical shift, and it is the triplet, so most probably this is the signal of this methyl group, and CH2, because the neighbor has 3 hydrogen atoms, so it is split into quartet. So there is a quartet. So this should be CH2, and this whole signal is merged together due to these 5 hydrogen atoms, 1, 2, 3, 4, 5. And here in 1,2-dioic acid, benzene 1,2-dioic acid. So in benzene 1,2-dioic acid, as we have seen that there is CO2H, CO2H. So here benzene, the signals for benzene must be there, and the protons could be here. These protons could be here, and these could be the protons of the benzene ring. 1, 2, 3, 4. These 4 protons could be there. Remember that there is no proton on these positions. These two gives the similar peak, and these two gives the similar peak. See, if I zoom in, it is somehow a doublet. So it can give a doublet, okay? But this too much detail is not in our syllabus. Explain the use of CDCl3 instead of CHCl3 as a solvent when obtaining these spectra. So you know that actually CDCl3 is a deuteriatic solvent where deuterium is used, and deuterium does not cause any peak. Okay, although due to the little exchange at 0 there might be a peak, but sorry, this CDCl3 has no peak. Okay, so because CDCl3 is no peak and does not interfere with the peaks of the sample. Okay, now the part question says that identify the substances shown by the spectrum figure 6.1 and complete table 6.1. So we have already discussed that the figure for 6.1 is ethyl benzene. Ethyl benzene. And the peak at 1.2. 1.2 is here. This is the triplet. So name of the splitting pattern is triplet. And while the name on the 2.6 is quartet that we have already discussed. Quartet. Group responsible for this peak is CH3. And group responsible for this peak is CH2 that we have already discussed. It gives quartet because one peak because of this, and it is split due to these 3 protons into 4. And explanation of the splitting pattern. Why? Why? Because neighbor has 2 hydrogen atoms in ethyl benzene. So one signal is because of this, and it is split into 2 further peaks into triplet because of the neighbor hydrogen atoms. So the reason is 2 hydrogen atoms on SCH2 or on carbon atom. And here 3 hydrogen atoms of CH3. You can use alternate phrase. Identify the substance shown by the spectrum in figure 6.2. So figure 6.2 is benzene 1,2-dioic acid. So name of the compound is phthalic acid or benzene 1,2-dioic benzene 1,2-dioic acid. Okay, now group responsible for 7.8. This 7.8, this is 7. So this is 7.8, very near to this. The group responsible for this peak is aromatic hydrogen on benzene ring. Hydrogen on benzene. So the 4 hydrogen on benzene ring are there, which are responsible uh, for these peaks. And peak on 13.1, it is due to the carboxylic group. As on benzene ring, 2 carboxylic groups have, each one has hydrogen, and the spectrum was taken in CDCl3. So that's why these hydrogen would be there. So it is due to COOH. So these are responsible. You can write carboxylic acid as well. When D2O is used as a solvent, the spectrum obtained in this different from the spectrum in figure 6.2. So when we use D2O, deuterated water or heavy water, So there is an exchange of these OH. Either the OH is an alcohol or carboxylic acid or amine. So that peak would not be there. So we can write that the peak of the peak at chemical shift, that is delta 13.1, will disappear because of proton exchange. Because if instead of this solvent has too much deuterium, so deuterium can be replaced or exchanged. So now this peak cannot be seen there. And now this is the last question. Benzene dioic acid, benzene 1,2-dioic acid can be used to produce K. K is its anhydride. This is phthalic anhydride or benzene 1,2-dioic acid anhydride. So suggest the name of this type of reaction. The name of this reaction could be dehydration, because water is removed, OH from any one of them and H from the other. So it could be dehydration. It could be elimination, because water is eliminated. And you can classify it as auto condensation, because there is a condensation between these two groups. So several names can be used for here, but the most common one is the hydration. So that is the question from October November 24 paper 43. So inshallah next video with next question. Allah Hafiz.